So good morning, afternoon, and evening, everyone. My name is Xueting Wang, and thanks for giving me this chance to present my job market paper titled as Present Bias for Monetary and Dietary Rewards, Evidence from Chinese Teenagers. So this paper is co-authored with my supervisors, Stephen Chong and Agnieszka Zimola. Three of us are from the University of Sydney. The lack of self-control is thought to explain suboptimal choices and outcomes in many life domains, such as finance, health, education, and so on. In economics, researchers usually model problems of self-control through time-inconsistent preferences. And in the literature, there are two well-known models, hyperbolic discounting and quasi-hyperbolic discounting. The latter model has an attractive analytic features which have contributed to its popularity in the literature, and therefore in this paper, we're going to use the terminology of the quasi-hyperbolic discounting. So agents will have a present bias toward the current consumption as the value of the future rewards are downward relative to the rewards in the present, in addition to the standard exponential discounting of the delayed rewards. In the literature, we found that experimental evidence on this present bias largely relied on time-dated monetary rewards. However, the self-control issue or the quasi-hyperbolic discounting has been applied to many other domains which are less related to money. For example, in the health domain, the obesity problem gets more and more serious over time globally. And therefore, a question that in our interest is how informative the time preference for money is to the time preference for other reward types, such as food. And with this, I'd like to summarize some issues we think that exist in the literature and our contributions through this paper, and also an overview of our relevant findings. First of all, as I mentioned, that the current literature largely rely on monetary rewards. However, it's less clear about the present bias in money versus other domains. In the meantime, it's also unclear about the correlation of the patient's and the present bias across different domains. Now, our experiment elicits and compares utility curvature, present bias, and discount factor for money, healthy, and unhealthy food. We also look at the correlation of patients and the present bias across these different domains. In a nutshell, we find a strong present bias towards money and food. In addition, most current studies connect the data with university students. These students, they sign up to these experiments and they also manage to show up to these experiments on time. And probably this is the group of individuals who experience less self-control per se. We connected data with adolescents who are from low to medium socioeconomic status, which probably one of the main groups that experience a lot of self-control issue, and also is a group that has been less studied in economics literature. And we found that this group show considerably more present bias towards money comparing to the finding in the existing literature. Last but not least, few studies actually tested whether their preference estimates can predict the field behaviors. In our experiment, thanks to the collaborating schools, we're able to correlate our preference estimates to BMI, smoking, drinking alcohol behavior, and academic performance. And we found that preferences estimated over monetary rewards seem to predict more field behaviors comparing to the food. Now let me explain our experiment design, starting with the timeline. To elicit both patients and present bias, we use a longitudinal design. The whole experiment lasted for 5 weeks. In week 1, we came to the school and asked students to decide how much rewards they would like to receive in week 2 and in week 5. So in this time, both rewards are available in the future. 1 week later, we came back to the school and asked the students to decide again about how much rewards they would like to receive immediately and in week 5. So now the rewards that are available at the sooner date is available immediately. And to measure the present bias, we can compare their decisions made for week 2 in week 1 to their decisions made for week 2 in week 2. To incentivize their decisions from the both sessions, in week 1 session, we tell the students that in the end of this experiment, their decisions from either week 1 or week 2 session will be randomly selected, and that will determine their payments from participating in this study. We use this longitudinal design because this is the only true test of time consistency without any confounds from time stationarity. To equalize the transaction cost over attending these 2 sessions, we conducted experiments in the classrooms during the regular hours. And we also address this transaction cost issue when we design the choice sets, and I will explain that in a second. Moreover, no students opted out during our experiment, and therefore there is no self-selection issue in this project. And now let me explain how we construct our choice sets. We closely followed Andreoni and Spranger's convex time budget design. Here, I plot the awards that will be available on the sooner date on the horizontal axis, and the awards that will be available on the later date on the vertical axis. Each line I will show in this space will represent one trial that subject will face in the real experiment. For this specific trial, you may note that both vertical and horizontal intercepts are the same, 70, which implies that the simple interest rate for this trial is 0%. In other words, no matter you wait or not, the total amount of awards that you will get for these 2 dates will be exactly the same, 70. We use the discrete version of the CTP design. So on each budget line, we select 6 evenly spaced dots and represent them as 6 options in one trial. And the subject's task is to compare these 6 alternative bundles and choose the most preferred. And you may note that we intentionally do not include the corner bundles in our options, and we have 2 reasons for doing that. Firstly, it has been shown that with corner solvers, it will have some issues in doing structural estimations. But more importantly, because we only give the interior bundles as options, so every participant must allocate the rewards on the 2 dates, and therefore the transaction cost for attending both sessions are equalized across all individuals. So this is the this is a sample screen that is correlated to that 0% interest rate. We represent each option as one row in the screen, and the dots in each row are represented the size of the option that they could receive on one date. And we hope that we could use these dots to help the participants to make these comparisons more easily. And subjects just go through these 3 options and then find and choose the most preferred one by clicking it, and that one will be turned into red, and then they click next to move on. Now we have, and here are the other 6 interest rates that we use to elicit the time preference parameters. With the interest rates varied between the sooner date and the later dates, a subject's choices will trace out a price expansion path in terms of the sooner and the later rewards, along which the optimal choice, which is the selected one, will be dependent upon both on utility curvature and the discounting parameters. Here comes our interesting variation of the original CTP design. So we modified the original CTP by adding another set of trials that are represented by blue lines here, in order to allow us to also measure the participants' irrationality as gap violations. So in total, there will be 14 decisions or 14 trials for each reward type. And if you have that sharp eyes, you may notice that the budget line with 25% interest rate will appear twice in each session, and it can serve as a simple consistency check. Even though we don't have we don't have all participants choose exactly the same bundle for this repeated trial, but we feel there is a good portion of participants who do that. Moreover, the budget lines with 0% interest rate are parallel to shift, and therefore it can serve as an income effect text. In other words, we're checking whether you are going to change your preferences when you become richer. And we found that 72% of participants chose the same bundles for these 2 parallel shifter trials, and that's we conclude there is no income effect in this subject. So we programmed the whole experiment using Qualtrics, and this is a choice screen that subjects would face in the first session. And this is the choice screen that they would see in the second session. So everything is exactly the same, except the due date of each reward will be different between these two sessions. To cater different preferences for healthy food and unhealthy food, we provide the 3 options of each category. And in the beginning of week 1 session, we ask students to select 1 favorite healthy food and 1 favorite unhealthy food to be the rewards that they will make decisions for afterwards. So to summarize, for each reward type, there are 14 decisions to make in each session. This is a within subject design. Therefore, in each session, each subject will make 42 decisions in total. In each decision, the order of that 6 bundles is randomized. And also the order of these reward types is randomized as well. It could be either healthy food, money, unhealthy food, or unhealthy food, money, and healthy food. This order is randomized in the first session, and it's kept constant in the second session. In terms of payment, in addition to what I mentioned before, we also don't pay show-up fee to the students because it's us who came to the schools who conducted the experiment. And also without show-up fee, this will help participants to really think about their choices in the experiment. We conduct this experiment with 4 public high schools in China, and in total, we get 697 participants. Around half of them are boys and half of them are girls. Okay, now let me go through the results, starting with the consistency check. Firstly, the maximum number of possible GOP violations in our design is 91. On average, in each session, our participants made less than 2 GOP violations, and this gives an effort index as 0.98, which is very close to a perfect consistent chooser who has an effort index as 1. And therefore, we conclude that our participants made highly consistent choices within each session, establishing our assumption of maximizing a lossless utility function when we do the structural estimation. And now let's focus on the results of the time preferences. So I'm going to show you the results obtained by using both non-parametric measurements and also the structural estimation. For the impatience, to exclude the confounds from the present, the non-parametric measurements will only use the decisions that made in the week 1 session. And therefore, the impatience will be calculated as the proportion of a reward allocated to week 2 in week 1. So here, I plot the simple interest rate on the horizontal axis and the proportion allocated to the sooner date on the vertical axis. The dots and the solid gray lines are decisions for money. So what would we expect to see for rational choices? When the interest rate goes up, you're going to save more because the return is higher, and therefore you are going to choose to allocate less to the sooner date. And this is what we found for monetary rewards and also for food rewards as well. Moreover, you may notice that the square sign and the cross sign are generally above the dot sign, which indicates our participants are more impatient for food than for money. And this has been proved using a 2-sided t-test. The present bias is talking about how much reward you are going to allocate to the sooner date when the sooner date is in the present versus when it's in the future. And therefore, the non-parametric measurement of the present bias is the difference between the proportion of a reward allocated to week 2 in week 2 and the proportion of rewards allocated to week 2 in week 1. So in this graph, we plot the decisions from both sessions for each reward type separately. The dots and solid lines are for the decisions that are made in week 1 session, and the squares and the dashed lines are the decisions that are made in the second session. If participants make consistent choice, then when they make decisions in week 2 again, they're not going to change their choices, and you are going to expect that the dashed line and the solid line will be overlapping to each other. But if participants show present bias, then we would expect to see that the dashed line will be above the solid line. And this is what we see for all 3 reward types. Moreover, the distance between these 2 lines will give the signal of the strength of the present bias. And it seems that we find a stronger present bias for monetary rewards than for food. So to summarize, adolescents are more impatient for food than for money, and this is in agreement with the existing literature. Interestingly, our novel finding is that adolescents also show present bias for money, healthy and unhealthy food, and the present bias is stronger for money than for food. And now let's look at our results obtained using structural estimation. For the instantaneous utility, we use CRRA utility function, and the intertemporal utility is described using quasi-hyperbolic discounting model, where beta captures the present bias. When it is smaller than 1, then it shows present bias. Because of the discrete nature of our choice sets, we're going to use the multinomial logical regression to estimate the parameters. So we firstly calculate the discounted utility of 6 alternative bundles in terms of sooner and later rewards. And then given the actually selected choice, the multinomial logic probability of the observed choice is given by this formula. The estimates of alpha, beta, and delta are selected in order to maximize the log likelihood of the observed choice. And here is the results that we obtained using the aggregate level estimation. So let me start with the middle column of beta. Firstly, we found that the beta are all significantly smaller than 1 and indicates that for 3 reward types, our participants shows present bias. In terms of the utility curvature for monetary rewards is not significantly different from 0, which indicates a linear utility for money. But for food, we find a more concave utility. In terms of the delta, which is a discount factor, we found that the delta is greater than 1, which implies a negative discount rate. So this is a bit surprising and also very interesting. Now I don't have time to go through the detailed explanation for this, but if you're interested, you can ask me later or move to our paper for the detailed explanation. With the aggregate level estimation, we conducted a cross-equation test for the equality of the preference estimates across these 3 reward types. Now, in short, both alpha and beta, they differ between money and food, but they don't differ between healthy and unhealthy food. The delta does not differ between any reward types, and therefore jointly, all these parameters are differing between money and food, but they don't differ between 2 foods. To summarize, aggregate estimation confirmed that participants are less patient, less present bias, and have more concave utility for food than for money. And now let's look at the correlation of the patience and present bias that across the different domains. Here is the scatter plot of the delta that we obtained using the individual estimation. And we see that there is a positive correlation between the delta for money and food, and the correlation coefficient is around 0.6. So we're not going to comment whether this is a strong correlation or not, because we don't find a consistent conclusion about this correlation coefficient, and therefore we're going to interpret this as a moderate correlation. And we also see a similar moderate correlation in terms of present bias across the different domains. So to summarize, the individual estimates of time preference were moderately correlated between money and food. And last but not least, we're checking whether our preference estimates could predict the field behaviors. So here, this table is obtained by running 12 linear regressions. So for example, firstly, we're going to regress the BMI with the impatience measurement for monetary rewards by controlling these variables that I listed here. And the coefficient in front of the impatience for money is negative 2.92. And similar for the other numbers in this table. So generally, we found that people who are impatient towards any reward type are more likely to drink alcohol. And people who are more impatient for monetary rewards and unhealthy food are more likely to have lower grades in the scores. So all these findings are in the expected direction, even though the significance level is not that strong. Will the present bias have a stronger correlation with the field behaviors? It turns out not. So when we run the regression between the field behaviors and the present bias measure of these three reward types, we find that kids who show stronger present bias towards money are more likely to smoke, drink alcohol, and have lower grades in the schools. But we don't really have much findings about the food and the field behaviors in terms of the present bias measurement. And therefore, to summarize, measures of patients have stronger associations with field behaviors than measures of present bias. Moreover, time preference for money predict more field behaviors. And with that, I'd like to thank you for your attention, and I'm excited to hear Anya's discussion of this paper. Thank you.